Yes, students, as you all know that in the last class we were discussing the chapter motion. Please do remember this is today it is 24/6/2021. Hope that you all have mentioned the day, and even I believe that all of you are maintaining the notes with neatness. And even I am also believing that after every concept or every problem is over, you are drawing the line with scale and pencil, right? Shreya, Prashast, okay. Sanjana, yes. And one more thing, before commencing the class, just two information will be given. The first information is, you all know that today evening you will be having the performance test. Third performance test, it will be conducted through Google Form. And even I have already told you the syllabus. It is motion chapter up to equations of motion. And second important point is, every day I have been giving you the worksheet. Some students are really writing very well. I'll go for select such students on a day. One student's worksheet will be put in the group. So it will come in rotation wise. Got it? Yesterday, I had sent one student's answer sheet. She is Sanjana Ji. Hope that you might have observed. So like from even today also, I'll follow the same. I'll select just one student's worksheet and it will be put up in the group. Okay. Yes, students, you all know that in the chapter motion, we learned an important concept, that is equations of motion. And who has given the equations of motion? He is Sir Isaac Newton. How many equations he has given? 3 equations. Just go for recalling them. What are these? The very first one is, it is V is equal to U plus AD. Second one is S is equal to UT plus half AT squared. And third one is, it is 2AS is equal to V square minus U square. And even we have given a name for each of these equations as well, right? So yeah, could you tell what name has been given to first equation of motion? It is it is velocity time relation. First one is velocity time relation. Then okay, what is the second equation of motion? It is position time relation. Position time relation. Prashast, what do you say about third one? It is, you tell that I can hear. Yes, it is position velocity relation. Position velocity relation. And we had derived all these. But interesting thing is, for deriving all the equations, we will go for using only one type of graph. And even data is also same. What graph was used? Whether DT graph or VT graph. VT graph. Particularly with respect to VT graph, which one was used? Uniform acceleration or its constant velocity? Uniform acceleration. Hope that you all have remembered, even you have practiced as well. Okay. Now, and we were solving some of the numerical problems on equations of motion. Is it not? How many were over? Show the symbol, 1 or 2. 2 were over. Victory symbol. 1 was over. Second one, just I had given you as home assignment. Have you all done? Yes, very good, very good. Prashast, what answer you have got? Oh, it's okay. Okay. Now, let me go for taking the same statement. This was let me read the statement. It was like this. The brakes applied to a car produced an acceleration of 6 meter per second square in the opposite direction to the motion, right? Followed. Next, if the car takes 2 seconds to stop after the application of the brakes, then we have to calculate the distance it traveled during the time, right? Lakshmi Sri, have you done? Very good. Just if you have done, just go for cross-checking with my writing. If not, you can write with me. Here, I'll write the data. You all know that the brakes are applied to a car. We know that when the brakes are being applied, what happens? What happens to the speed of the car? The speed will go on decreasing, right? Well, finally, when it comes to rest, what will be the velocity or speed? It will be 0. Very good, very good. Some are showing like this. It is 0. And here, when the brakes are applied, the speed will go on decreasing, and hence there will be decrease in the change in velocity of a body in the unit time. We call this as acceleration or deceleration. It is deceleration, right? Here they have given the deceleration. It is 6 meter per second square. Now we have to take that as A is equal to minus 6 meter per second square. Hope we have written the same. Next, and it comes to rest after 2 seconds. That means after the application of brake, it has traveled for some distance, and the time for which it traveled, it is 2 seconds. We can write t is equal to 2 seconds. Then after 2 seconds, it comes to rest. When it comes to rest, it will be its initial velocity or final velocity. Final velocity. Final velocity, it is v is equal to 0. Next, with this information, we have to calculate the distance traveled during this time. That means, what is the distance covered by the car in 2 seconds? That should be found out. S equal to question mark. Okay, now let's go on to calculation. Okay, we know the acceleration, time, and velocity. We want displacement. So to find out the displacement or distance traveled by the car, you will go for using either second equation or third equation, right? Okay. In second equation, S equal to ut plus half at square is there. Do you know its initial velocity? Unknown. So it cannot be taken. Next, go through third equation of motion. 2as equal to v square minus u square. You know that acceleration and displacement has to be found out. Final velocity, you know. Do you know initial velocity? Here also it is unknown. So both cannot be taken. Both cannot be taken. Yes. Lakshmi say out. No. Very good. So then we have to take first equation of motion. Again, to find out the displacement, we need initial velocity. To find out initial velocity, we have to use the first equation of motion. You will write by equation of motion, that is v is equal to u plus at, where final velocity is 0, initial velocity is unknown, plus acceleration, here it is deceleration. This is minus 6 and time is 2 seconds. So it is 0 is equal to u. 6 into 2, 12. Minus sign is there. So minus 12. Then transfer minus 12 to the left hand side. It becomes plus 12. Then it can be written u is equal to 12. But what is the unit? Yes, very good. It is meter per second. They have given in meter and seconds only. It is the initial velocity of the car. Now, as you know, initial velocity, To find out the displacement, either you can go for second one or third one. Yaudu? This one, victory. Okay. Let's go for using second equation of motion. Can we go for using third? Third can also be used, but you are liking most second equation. I'll take the same. Again, by equation of motion, that is S is equal to ut plus half at square. This is equal to where u is 12 meters per second and time is 2 seconds plus half into a is acceleration minus 6 and t is it is 2 whole square. This is equal to 12 twos are 24 plus here 2 ones are 2 threes are. This is minus 3. Then 2 square is it is 4. 24 minus 3 into 4 is it is 12. 24 minus 12 is it is 12. Have you got the same? CK, Prerna, Manya J Jain. Okay. Then could you tell what is the unit? Yes, unit is meter. Then don't write meter per second because it is a distance. So S is equal to 12 meter. And in 2 seconds, the car has covered or car has traveled a distance of 12 meter. Write the conclusion. If the distance traveled by a car, distance traveled by the car is 12 meters. The distance traveled by the car is 12 meters. Yes. 2 numerical problems are over. I'll go for taking another one. And this was, yes, it was given in the examination. Please put double star mark and write. This third one, and I've been giving from the textbook. The question is like this. A bus starting from rest. A bus starting from rest. Starting from rest. Moves with a uniform acceleration. Moves with a uniform acceleration of 0.1 meter per second for 2 minutes. For 2 minutes. Full stop. Find in that A is the speed acquired. The speed acquired. And B, this is the distance traveled. The distance traveled. These are the 2 physical quantities which we have to find, which we have to find out. Is it not simple? When you are writing only, just keep on understanding the statement. Then it will be easier. Manya Jai, have you copied? No, still you are copying. Copy. Very good girl. Good girl. Okay. Ekta, have you copied? Yes. Mohita Viji, copied or copying? Copied or copying? Yes. And Niharika, Okay. Yes. Just you should go on writing the data with me. Before that, once you go through the statement, the statement is a bus starting from rest moves with a uniform acceleration of 0.1 meter per second square. Dear students, could you tell first what can be written in data? Prashant sir, you may unmute everybody.
Sir, we done this problem yesterday.
Yes, sir.
Yes, sir.
Yes, sir.
Sir, this is
We
first
done this.
question.
Finish, sir.
Finished, sir. You did?
Yesterday this problem was solved.
Okay, let us do one thing. As a problem, don't go for striking it out. Instead, just let us go for changing the numbers. Right. Attains a bus starting from rest moves with a uniform acceleration of 2.4 meter per second square in 3 minutes. In 3 minutes, the speed acquired and distance should be found out. Yes, let's go further. Let us write the data. If so, what can be written? A bus starting from the rest. As it starts from the rest, what is its initial velocity?
Zero.
It is 0. Right. U is equal to 1. Then it has obtained the acceleration of 2.4 meter per second. 2.4 meter per second. Then for 3 minutes, so time it is 3 minutes. Whether all of them are in SI units?
Sir, 3 minutes.
No.
Sir,
180.
3 minutes.
180 seconds.
180 seconds.
Very good. Convert 3 minutes into seconds. 3 into 1 minute is 60 seconds. Then 60 into 3, it is 180. 180 seconds. With this information, we have to find out the speed V equal to question mark and the distance traveled S equal to question mark. Calculation. Then could you tell how do you go for finding the speed? You know that.
First, we have to calculate final velocity.
You can find out speed by using only acceleration formula or else first equation of motion.
First
Both are
equation.
same only.
First equation.
First equation of motion, right?
First equation.
By equation of motion, that is V is equal to U plus AT. It's equal to V's final velocity is unknown, but initial velocity is known. It is 0 meter per second. Plus acceleration is, this is 2.4 meter per second square, and the time is, it is 180. It's equal to 2.4 can be written as 24 by 10, then into 180, 0, 0 get cancelled. It is equal to multiply 18 4s are 72. 7 is the carry, 18 2s are 36. 36 plus 7.
43.
43. 432 meter per second. I think it is too much. Let it be. Just let us consider only for calculation purpose, not practical way. B1, right? We have to find out the distance. How do you go for finding the distance?
Second equation.
Second or third equation.
Second equation.
All the terms are known. Shall we move on to third one?
Yes, sir.
Okay.
Yes, sir.
Again, right? By equation of motion, that is 2as is equal to v square minus u square. Then it is 2as, 2 into a is 2.4 and s is unknown. It is equal to v, it is 432, right, whole square, minus u square, u is 0, right, 0 whole square. Then it is to be written as s is equal to, just look at the word, 0 whole square is 0. Any number minus 0 is the same number itself. Hence, I'll write 432 square as it is. 432 into 430. Transpose 2 into 2.4 to the denominator. 2 into 2.4. Now you may go for cancelling by 2. 2 ones are, 2 twos are, 1s are, 6 are. 216 are. Then 2 1.2s are. Here again you can cancel it by 2. 2 1s are, 0s are, 8s are. You got 108. Then again you can cancel it by 2. 0.6. Then 2 5s are, 4s are. Again it can be cancelled. But I'll write it in one step. That is 54 into 432 divided by 0.6 is there.
Sir, you wrote
Right.
only
The
43.
432.
32.
Into 10. 0.6 is written as 6 by 10. Take the reciprocal, it will be 10 by 6. Hence, I have written 10 on in the numerator. Now you may go for cancelling. Here 2. 2 3s are 6. 2
Sir, you can cancel direct, sir. 6 ones are 6 nines.
okay. 6 9s are a direct cancel. 6 1s are 6 9s are. Now you first multiply 432 and 9. 9 2s are 18. Carry 1. 9 3s are
27, 28
28.
to carry
9 4s are 36 plus
3888
into 10. It is 38,880
80.
meter. If it is converted into kilometer, how much it will be?
38 kilometers. 880 meters.
38.88 kilometer.
38.88.
38.88 kilometers. This is the distance traveled by the bus. Over. Yes. Let me go for taking another one. Right, quick as possible. It is fourth one. Again from the textbook, and this was also given in the examination for 1 mark. 1 mark. You just put single star mark and write 1 mark. The question is like this. A train is traveling at a speed of 90 km per hour. A train traveling. A train is traveling at a speed of 90 km per hour. Kilometer per hour. Full stop. Brakes are applied. Brakes are applied. When brakes are applied, what happens to the speed of the train?
Decreases.
Speed of the train, it will
Decrease.
decrease.
Decreases.
Then whether you consider negative acceleration or positive acceleration.
Negative acceleration.
Negative acceleration.
Deceleration.
That is nothing but deceleration. Brakes are applied so as to produce a uniform acceleration. Uniform acceleration of minus 0.5 meter per second. ಅವರೇ ಕೊಟ್ಟಿದ್ದಾರೆ. Full stop. Find how far the train will go before it is brought to rest. Find how far train will go. Train will go before it is brought to rest. Before it is brought to rest. So before coming to rest, how much distance it will travel, that should be found. Please observe, once you go through the statement, observe the physical quantities and know their units as well. Yes, go on writing with me. Once you go through the statement, a train is traveling at a speed of 90 kilometers per hour. Could you tell what does it represent?
While it was in motion, the
Distance traveled by a train.
speed.
90 kilometers per hour. It is the speed with which the train is moving. Nothing but it is its initial speed. Got it, Rakshita?
Yes, sir.
Right. Initial speed u is equal to 90 kilometers per hour. And observe, another physical quantity has been given. It is with meter per second. So that let us
90 into
convert
5 by
kilometer
18.
per hour into meter per second.
Meter per second. 25 meter per
90
second.
into 5 by
So 5 by
18.
18.
5 by 18 meters per second. Now let's go for cancel. 18 ones are 18 fives are 5 fives are
Meter per second.
meter per second. Have you got same?
Yes, sir.
Now go to this. Brakes are applied to produce a uniform acceleration of minus 0.5 meter per second square. Obviously, as the brakes are applied, the speed will go on decreasing. Hence, the train will move with negative acceleration.
Deceleration.
It has been given. A is equal to minus 0.5 meter per second. Next. Go to this. Find how far train will go before it is brought to rest. When it comes to rest, what
Final
will be the
velocity.
final velocity?
0.
It is 0. How far it will travel? We can write. We have to find out. Yes. Let's go for calculation. Yes. Will you go for using equations of motion or else general formula?
Equation.
Equation of motion.
Equation
Which
of
one?
motion.
First one, second one, third one.
First one.
First one.
Third one, sir.
No, third,
Time
third.
is not
The
given, sir.
second.
First.
Second one.
Third one, sir. Because time is not given.
one. First one, sir.
Time is not
I'm
given.
asking you the question, but the reply is you are giving me the option. Because you
one.
are all telling that. Sir,
Third one.
second one, third one. Andre, ಈಗ ನಾನು ಅದರಲ್ಲಿ choose ಮಾಡಬೇಕು. Out of 3, one should be chosen correctly.
Third one.
Third one.
Third one.
Initial velocity, acceleration, final velocity. Initial velocity, acceleration, final velocity. We want distance.
Yes, sir.
So let's go for using that. It is most suitable one. Second one cannot be used. ಯಾಕೆಂದ್ರೆ there time has not been given. That's why we have to use third equation of motion. Right. By equation of motion. By equation of motion, you can write 2as is equal to v square minus u square. Substitute 2 into a is minus 0.5 into s, that's equal to v square, v 0
Zero.
minus
Minus
u square
25 whole square.
25.
whole square. 0.5 into 2. How much it will be? It is. How much?
1. 1.
One.
1. So it is minus, yes, this is equal to 25 whole square. 625. Here
25.
minus 620. Can we write directly as value? This is equal to
Minus will get cancelled.
minus
625 meters.
cancel, it will be 625. So before coming to rest, the train has traveled a distance of 625 meters. Over.
Yes, sir.
And rub it. See, it has been given only for 1 mark because it has simple calculation. For 1 mark, you can write directly just by using the equation of motion and substituting. The final answer. Fifth one. Fifth one. Yes. This is also simple one. But this conversion, it was given in the examination for 1 mark. Put single star mark and write 1. Put single star mark and 1 mark. The question is like this. A trolley while going down an inclined plane. A trolley while going down an inclined plane. An inclined plane. It's like this. It is inclined plane. Here is the trolley. While going down, incline the plane. Now you tell whether it takes the acceleration or deceleration.
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 You both options. When you are going down, see that you are moving like this. Whether speed will go on increasing or decreasing? Increasing. Then the speed is being increased with respect to time. Whether it is positive or negative acceleration.
Negative.
Negative acceleration.
acceleration.
Positive acceleration.
Those who are telling negative acceleration, really you have idiotical thinking. It's very unfortunate. It has been given clearly that as it is going down, the speed will go on increasing. Speed increase agutte andre, then obviously it will be positive acceleration, or just we go for taking acceleration. Right now. Simple ide anta sunna hange bitbiಟ್ರೆ I think probably some students will go for writing negative only. ಈ problem ಏನಾದರೂ exam ನಲ್ಲಿ ಕೊಟ್ರೆ please has an acceleration of 2 centimeter per second. Centimeter per second square. Please do consider the unit. Full stop. Right. What will be its velocity? What will be its velocity after velocity 3 seconds after the start? After the start. Observe. Look here. Please go through the given statement once. A trolley, while going down in an inclined plane, it takes the acceleration that has been given. It is 2 centimeters per second square. And they have also given the statement that it will travel for 3 seconds. Time has been given 3 seconds. Ritika, look here. Travel for 3 seconds. After that, it will come to rest. Then obviously, final velocity will be 0, right? And we are going to find out what will be its velocity. When it is moving, what was its velocity? That should be found out. So let's go for writing the data.
6 meters per
Okay.
second.
Very good. Right. Somebody told the answer, please tell. Once you
6
repeat.
meters per second, sir. 6 centimeters per second. Centimeter per
Very
second.
good, very good, very good. Here I'll write data. Acceleration has been given. It is 2 centimeters per second square. Next, what will be its velocity 3 seconds after the start? Time has been given. T is equal to 3 seconds. Next, it comes to rest after 3 seconds so that final velocity will be 0.
So we
And
should
you are going
convert
to find out
acceleration.
initial velocity, right?
We should
Now-
convert acceleration.
No need to go for conversion. ಯಾಕೆಂದ್ರೆ ಇಲ್ಲಿ time is given in second. Here also second. So ಇಲ್ಲಿ ಏನಾದ್ರು distance, if anywhere else, if the distance is given in meter, then we would have converted this into meter. It's not necessary here.
Sir, final velocity how will be 0? Sir?
Who is asking? Please tell your name.
Stress.
Shreyas. What will be its velocity 3 seconds after the start? Sorry. Initial velocity will be 0. You are going to find out final velocity. Andre, it starts from a point. Before starting, it was at rest, so that it will be initial velocity is 0. Then it will keep on moving, but we are going to find out what is its velocity after 3 seconds. Got it?
Sir, we can also convert acceleration into meter per second, no, sir?
Meter per second square. Of course you can.
Okay, sir.
Here it is not necessary because other distance has not been given in any other unit. Write the calculation. How do you go for finding the final velocity?
First
By
equation.
using
First equation of motion.
First equation.
Or else you may go for using even acceleration formula also. Yakendre not a, t, u and v. A is equal to v minus u by. All the terms are. Here also the same terms are. Okay. Any one of these two? As you said, I go for equation of motion.
Answer is 6
By equation of motion, v is equal to u plus ab. Then initial velocity is 0, acceleration is 2 centimeters per second square, and time is 3 seconds. It is equal to 6 centimeters per second. Here it has been calculated in centimeter. You ಬೇಕಾದ್ರೆ ಅದನ್ನ ನೀವು meter ಗೆ convert ಮಾಡಬಹುದು. V is equal to 6 centimeters per second. Or here V is equal to 6. Convert centimeter per second into meter per second. You all know that
600 meter per second.
how many centimeter, how many meter is equal to 1 centimeter?
100.
100.
100.
1 by 100. 1 by 100.
1 by 100.
You question ಕೇಳಿದಾಗ think ಮಾಡಂಗಿಲ್ಲ. I am asking you how many meter is equal to 1 centimeter, not how many centimeter is equal to 1 meter.
22.77.
Look here. You all know that 1 centimeter is equal to 1 by 100 meter. ಇದು ಹೆಂಗ್ ಗೊತ್ತಾಗುತ್ತೆ ಅಂದ್ರೆ you are also familiar with it. 100 centimeter is equal to 1 meter. Either 1 centimeter part. 1 centimeter is equal to 1 by transpose 100 to the denominator. 1 by 100 meter.
0.0.
Here 6 into 1 by
0.06 meter.
meter per second as it is. Now cancel it. It will be
06
0.06
meter per second.
meter per second. ನೀವು ಫ್ರಾಕ್ಷನ್ ಅಲ್ಲಿ ಬರೆಯೋದಾದ್ರೆ it is
Sir, 3 by 50.
250 ಹಂಗಾಗುತ್ತೆ ಅಷ್ಟೇ 3 by 50. Let it be in meter per second in decimal. V is equal to 0.06 meter per second. This is the velocity of the trolley after 3 seconds. Right. Therefore, the velocity of the trolley is 0.06 meter per second.
Sir, I got 3 by 50 meter per second, sir, answer.
See only. What you have done is you have cancelled only. 2 3s are 250s. ಹಂಗಾಗಿ ಅಷ್ಟು ಬಂದಿದೆ. Next one, even this was given in the examination. Very nice statement it is. I'll give you that. And put double star mark on this. Sixth one. Right. A stone is thrown in a vertically upward direction. A stone is thrown in a vertically upward direction. A vertically upward direction. With a velocity of 5 meters per second. With a velocity of 5 meters per second. The velocity of 5 meters per second. Full stop. Now you tell whether it takes acceleration or deceleration.
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 When the stone is thrown vertically upward, its speed will go on decreasing. When it reaches to some height, its speed becomes zero. When it becomes zero, then it starts falling towards the ground. Got it?
Yes, sir.
ಇಲ್ಲಿ ಏನ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದ್ರೆ if the acceleration of the stone during its motion, if the acceleration of the stone during its motion, acceleration of the stone during its motion is 10 meters per second square. 10 meters per second square in the downward direction. In the downward direction. Full stop. What time will it take to reach highest point? What time will it take to reach highest point?
Sir, 0.5 seconds.
How did you say that? It is 0.5. Who said? Please tell your name.
Sir Yashwant.
Ishwant. Yeah, correct.
The displacement is 1.25 meters.
Displacement.
Is 1.25 meters.
Very good, very good. Oh, okay. Stop writing. The statement is very nice. Once you go through this, see that a stone is thrown in a vertically upward direction with a velocity of 5 meters per second. Just look at it. This is the ground. From here, we are throwing the stone vertically upward, and it is moving. It is thrown with some speed. It is 5 meters per second. That speed is 5 meters per second. If the acceleration of the stone during its motion is 10 meters per second square in the downward direction, look here. When the stone is thrown vertically upward with a speed of 5 meters per second, it will go on decreasing its speed. Finally, it reaches some height. After that, it starts falling towards the ground. When it is falling towards the ground, it moves with a acceleration of 10 meters per second square. Ashto acceleration is fall out. The question is, what time will it take to reach the highest point?
Time is equal
but we do not know what is the height to which the stone has reached, right? Is it not?
Yes, sir.
Now, first, let us write the data. First, what will write? What does 5 meters per second indicate?
Initial velocity.
Very good. Initial velocity given to the stone. Ashtu speed alli adana ಮೇಲೆ ಎಷ್ಟಿದೆ? So initial velocity u is equal to 5 meters per second. Next.
Acceleration.
As it is going up, the speed will go on decreasing.
Deceleration.
Negative acceleration.
Positive or negative acceleration?
Negative acceleration.
How much?
Minus 10. Minus 10, sir.
Minus 10 ಅಂತ ತಗೊಳ್ತೀವಿ. Minus 10 meters per second square. Allowed. Downward, it is plus 10 meters per second square. Upward, it is minus 10 meters per second square.
Sir, they gave 10-meter acceleration for downwards.
Oh,
Then it is positive now.
yeah, down. See, you are going to find out what is the time taken by the stone to reach the highest point. It is going up. And when it is going up, its acceleration should be known.
Yes.
That is why we have taken that acceleration, minus 10 meters per second square. When it is coming down 10 meters per second square, when it is going up, acceleration will be negative, minus 10. Did you understand?
Sir.
Listen to me. Listen. We know that when the object is falling towards the ground, due to gravitational force of that, we call that body as free fall body. Alva? Is it not? When the object is thrown vertically upward, it starts moving away from the ground, away from the surface of the earth. Then what do you call that object? Or what do you call that body? It is called projectile body. Projectile body. When it is falling down, when the object is falling freely towards the ground, it changes its velocity by equal amounts in equal intervals of time. Hangagi adana ನಾವು uniform acceleration ಅಂತ ತಗೊಂಡಿದ್ವಿ. ನೆನಪಿದೆಯಲ್ಲ? When the ball is falling towards the ground, it falls with a uniform acceleration. Similarly, when it is going up, again it moves with uniform deceleration. But in both the cases, the value will be same only. 9.8 ಅಂತ ತಗೊಂಡಿದ್ವಿ. ನೆನಪಿದೆನಾ?
Yes, sir.
When it is taking upward, Again, minus 9.8, minus 9.8. But here value avare kottibididare. That acceleration is 10 meter per second square. Hence, upward we will take minus 10 meter per second square. Understood?
Yes, sir.
Okay. Now, 10 meter per second square in the downward direction. What time will it take to reach highest point? When the stone reaches to highest point, what is its velocity?
0.
Final velocity.
Zero.
Zero.
Final velocity 0. Adu ena 0 agta idre enagutte? Stone will keep on moving upward. It never comes back. Okay. When it reaches the highest point, its final velocity will be 0. Right. V is equal to 0 meter per second. You are going to find out time. Calculation. How do you go for finding?
First equation.
Third combination.
First
Third
equation.
First equation. First equation.
Yes.
Third
By first equation of motion. Observe initial velocity, final velocity, acceleration. You want time. Okay. Final velocity, initial velocity, acceleration. All the three are known. We want fourth physical quantity, that is time. By equation of motion, we can write V is equal to U plus AT, where final velocity is 0, initial velocity is 5, and acceleration is minus 10, and time is unknown. It is 0 is equal to 5 minus 10 into t, minus 10t. Transfer minus 10t to the left hand side. It becomes plus 10t. This is equal to 5. T is equal to 5 by 10. T is equal to 5 by 10. It is nothing but 1 by 2. Also 0.5 second. Just 0.5 second. Andre half second problem. Half second to reach that highest point. But somebody told, sir, the distance it has traveled is 1.25. Somebody told 1.25. I don't know why they have found out the distance. In case, if they ask, find the distance traveled or find the distance of the highest point from the ground, then you can go for finding yes. Okay, in time of we have found out that much.
Sir, we can use T is equal to V minus U by A.
Pardon me? Once you tell.
Sir, we can use T is equal to V minus U by A.
V equal to?
Sir, if we can use T is equal to V minus U by A.
Acceleration formula, sir.
T is, you can. Should I? Helping verb should be used first. We can, can we use or could we use? Sir, could we use the formula T is equal to V minus U by A? This is the question you asked, no? I think.
Yes, sir.
This can also be used. Same answer you'll get. Okay. So now I'm going to rub it. Yes, students, do you know about helping verbs?
Yes, sir. Auxiliary.
Sir.
They are also called auxiliary verbs. Jackno, give some examples for these helping verbs.
Is, are,
Is,
am,
was,
were, have, had,
will,
does,
shall, will be, shall be, has,
Can.
Could be.
May.
had,
Could be.
can, could, may, might.
shall,
Yeah.
might.
Yes, sir. Okay. And when you are asking me, you should not go for using the helping verb can. Can anta use ಮಾಡಬೇಡಿ. Sir, can we write ಅಂತಂದ್ರೆ you are asking about, it means you are asking about your capacity. I don't know your capacity. You know your capacity. Alva? Instead, you may ask me like this. Sir, could we go for using this formula? Could we? You are asking me,
Can we?
you are requesting me. Don't use can we. That shows your capacity.
Shall I?
Shall I? I don't accept. It doesn't seem good.
May or could, sir?
May or yeah, may or could can be used. Those will show the politeness. Yeah, some of you will ask, shall I come? What is the meaning of shall I come in Kannada? Nan barla.
Olag
See,
barla.
this is the way you are. May I come? Nan barbahuda. See, which of these two is politeness? Will show politeness. May I come? Is
May
it
I
not?
come?
For politeness, go for using may or could. Yes. Now, we are moving to the next concept of this chapter. Listen. Dear students, let us go for taking some of the situations. One situation is, you have assumed that you have taken a thread and stone, some length of thread, right? It is of about 1 meter. One end of it is tied to a stone, and you will hold the other end. You start whirling over your head. Got it? And don't go for leaving it, because it may hit somebody else. Should be careful when you are holding. You are whirling over this. Then observe the stone. Could you tell what type of motion experienced by the stone?
Uniform
Circular
motion.
Very good, very good.
Circular motion.
Rotatory motion.
Stone and rotate ಆಗ್ತಿರಲ್ಲಪ್ಪ, rotate ಎಲ್ಲ. It is circular motion. It start moving in the circular path around a fixed point. Here, just observe. Here is a bar, and see that this is the stone, and this is thread, and this is hand is holding the one end of the thread, and you start whirling the stone over his head. It will be moving like this, right? So stone will experience the circular motion. Similarly, could you tell one simple general question?
Sir, like fan.
What, Prithvi? I think your voice only. I am familiar with your voice.
Sir, it is like a
Listen to me. Listen to me. Dear students, one general question and general sense question also. Could you tell how many stars are there in our solar system?
infinity.
Sir,
Countless.
Okay, countless. Then,
Sir, one sun.
Uncountable.
Sir, one sun.
hey, wait. Somebody has told one.
One.
Enough. Listen. In our solar system, of course, there is only one star, that is the sun. Nam solar system alli one star ashte irodu. That is the sun. Around this star, many planets are revolving, right? How many planets?
8.
8
planets are revolving.
Planets.
Each planet is very close to the sun.
Mercury.
What is the shape of the path on which the Mercury moves around?
Oval.
Circular motion.
Jaknur, you are telling oval shape.
Yes, sir.
Elliptical.
It is
Sir, the orbit is oval shape, sir.
only
Circular, sir.
will revolve around the sun in the circular path, whereas other planets will revolve in elliptical path. Whole path anta helidala, that is elliptical path. That is why I took an example of Mercury. Listen, so like that we can give many examples for the circular motion. Even we have defined the circular motion as well. When a body moves around a fixed path, when a body moves around a fixed path in the circular path, then it is called circular motion. Once I repeat, when a body moves along the circular path around a fixed point is known as circular motion. Just you have given some examples for circular motion. Now I am going to take again the same example. Here is the sun and a planet is revolving around it, and this is the planet. Now you tell that whether the planet is experiencing accelerated motion or non-accelerated motion.
Accelerated motion.
Accelerated motion.
How do you say that?
Sir, because there is change in velocity, in the direction of velocity.
Okay. Here it changes its speed or velocity. How do you say that it changes its speed or velocity?
Sir, it changes its direction, sir.
As it changes its direction. Okay. Just I'll give you another situation. Assume that this is a square field. I name it as A, B, C, D. A person starts moving from A. He reaches to B. Then obviously to reach C, he has to take turn. Right? It changes the direction. As it changes the direction, whether it changes its speed.
Yes,
No,
sir.
sir.
Yes, sir.
Of course,
Yes, sir.
changes.
Yes, sir.
The direction change aಗುತ್ತೆ. 1 time, here 2 times, here 3 times. Then finally complete position. The number of times, number of sides increase much. Again, 1 time, 2 times, 3 times, 4 times, 5 times, 6 times. Now he change his direction 6 times. When he changes the direction, obviously the speed changes. When the speed changes, we can say that it is accelerated motion. Right? In the same way, could you tell how times a speed is changed? N number of times. Many times. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
Sir, disturbance is there, sir.
like that.
Sir, some
Sir,
other
disturbance
sound
there,
is
sir.
coming.
Some other sound. Sir, disturbance is there, sir.
Prithvi, I heard. I accept your requisition. Observe. Now the body has changed n number of times. Suppose if the body is moving in a circular path, if a body is moving in a circular path, how many times it changes its direction?
Infinite time.
Infinite number, right?
Infinite.
That means as it changes its direction, then we can say that it changes its velocity or its speed as well. As the speed changes, it gets accelerated. Hence, we can say that any body which is moving in the circular path will experience the accelerated motion, or the motion of a body moving in a circular path is accelerated. Clear up?
Yes, sir. Yes, sir.
Okay. Observe this part. If the body starts moving from A, you can tell the direction. In this case, it travels from A to B, then B to C, C to D.
Yes.
Here also, you can tell the direction if you go on mentioning some points A, B, C, D, and so on. But is it possible to tell the direction
No, sir.
or
No, sir.
No,
what is
sir.
the direction in which the body is moving in its circular path?
No, sir.
No, sir.
ಹೇಳಕ್ಕಾಗಲ್ಲಲ್ವಾ? But the students, just go. Let's go for recalling one mathematical concept. Could you tell which geometrical figure it is?
Circle.
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 I'm going to draw a line.
Circle.
That line is away from the circle. I'm bringing this line close to the circle. Again, still close to the circle. Now, let me draw again this line much close to the circle such that it will touch the circle at only one point. The line which meets the circle at only one point is called
Tangent.
tangent. It is called tangent. Followed? It is called tangent. Now, I go for giving you one of the situation, that is sharpening the knife. There will be a circular stone will be there. When it is being rotated, when you just go for holding that, you can observe the many sparks will be coming, right? Sparks
Yes,
node and the stone is rotating. The circular stone is rotating in the clockwise direction. And when you hold the knife to this, in which direction the sparks will be coming?
In opposite
The
direction.
direction in which
Direction opposite.
Opposite.
Opposite to the place where they have holding that knife, right? And okay, the direction of spark is to be termed as tangential direction. Got it? Tangential direction. The same way, if any body is moving in
The
the
definition of
circular path, it will be moving in tangential direction. Clear?
What is the definition, sir?
I'll tell you that. What? Somebody asked me something.
Definitions. Tangent.
Definition of what?
Tangent.
Tangent. The line that meets the circle at only one point. Very bad in I'll give you those points. A line that meets the circle at only one point is called tangent. When a body is moving in a circular path, it moves in tangential direction. Again, I'll go for giving you another situation. This is only. You have taken 1 meter length thread, one end of it is tied to a stone, you are holding the other end, you start whirling. When it is start whirling, by mistake somewhere else, the thread is broken. Thread break are there, in which direction it will move? Do you say that it moves in upward direction? It moves in downward direction? It moves in right side, left side?
the direction in motion, sir.
Yes, it moves in the direction of motion.
Direction.
Particularly, it will be tangential direction. Now let me give you a figure related to that. Look at this is a circular path in which the stone is moving in the anti-clockwise direction. Anti-clockwise direction. But it comes to this position, this, and this. I'm going to take the position A. This is the position of the stone A. When it comes to position A, the thread is broken. When thread is broken, now the stone moves in this direction. This is what we say tangential direction. Clear up? If the stone comes to this point, it moves in this tangential direction.
Yes, sir.
Artha aitala?
Yes, sir.
Yes.
Yes, sir. Yes, sir.
Explain once again.
When the body is moving in the circular path, the direction of its motion will be tangential. That should be remembered. Okay, next. When a body is moving in the circular path, when the body is moving in the circular path, is it possible for us to find out the speed with which it is moving?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, we can find out. But how do you say that it is? Assume that. Look at the object is here, or the stone is here. It covers or it completes one round in just 2 seconds. And the length of the thread is 1 meter. Then how can we go for finding the speed with which the stone will move? To find out that, you must know the total distance. Then what is the total distance?
2 pi r.
Very good. It is
2 pi.
nothing but circumference of the circle. Please observe the board. The speed of a body moving in the circular path can be found out by using the general formula distance by time. Distance is
2 pi r.
distance. If it completes one round, we call it a circumference. And the time taken by the body to complete one round, it is called time period, is denoted as capital T. And C, it is
2 pi r.
2 pi r. And T as this. So this is the formula used to find out the velocity of a body moving in the circular
path.
With respect to this, ಇದನ್ನ ನೀವು calculate ಮಾಡೋದಾದ್ರೆ V is equal to 2 into pi is 22/7 into radius. Radius is how much?
1.
1 meter.
Radius is
1
1
meter.
meter. And I
1
told you
meter.
the time taken to complete one round is 2 seconds.
2
So,
seconds divided
place
by
of play, I'll write 2 seconds.
2.
It is 1 sir, 1 sir. 22/7. It is nothing but 3.142857. But I'll just take 3.14 meter per second.
Meter per second.
Clear?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
When a body is moving in the circular path, if it covers equal distances in its equal intervals of time, then the motion of a body is said to be
Uniform circular motion.
circular motion. Andre,
Uniform
ಅದು
circular
it is moving
motion.
with a constant speed. Every time it covers the same distance in the same interval of time. For example, ಈಗ ನೀವು 1 second ತಗೊಂಡ್ರೆ, assume that it is covering a distance of 1 meter in 1 second. Next 1 meter 1 second. Or else if it covers 5 meter in 2 seconds, next also it covers 5 meter in 2 seconds. Next 5 meter in 2 seconds. Then this is called uniform circular motion. Did you understand?
Yes, sir.
What all the planets are revolving around the sun and the moon is revolving around the earth. They keep on covering the same distance in same intervals of time. Hence we can say that their motion is uniform
Circular motion.
Once I repeat, when a body is moving in a circular path, if it covers equal distances in equal intervals of time, then its motion is called uniform circular motion. Thus, look here. The thread that you are holding and which is tied to a stone, when you start whirling, will it move with the same speed?
No.
No, sir.
It all depends on
No,
how much force you will give. You ನಿಧಾನಕ್ಕೆ rotate ಮಾಡಿದ್ರೆ its speed will be having some value. But if you go on rotating little fast, again it will be changing. It depends on the force that we give. But the speed with which the planets are revolving, the speed with which moon is revolving around the earth, it is uniform circular motion. So it will
Sir,
be
it may
constant
change
with respect
time,
to
sir.
each.
Sir, it can also
Yes, yes.
it can also change the time, no sir.
Yado,
Moon.
please speak loudly.
Sir, moon will not be always in uniform circular motion, no, sir. Time can be changed.
I think Gaurav yes.
No, sir. Prajwal.
Huh?
Prajwal, sir.
Prajwal SM. Tell your doubt.
Sir, moon wheel can also change its time, no, sir?
No. How?
Sir,
It will be moving with a constant speed.
yes, sir.
There will be no change in the time. Got it? Prajwal SM.
Yes, sir.
Every day, of course, it rises late by some minutes. Pratidina ondondu time alli adu rise ಆಗ್ತಾ ಇರುತ್ತೆ moon. But don't relate that to the speed. Okay. Dear students, now we'll write about circular motion. Side heading, circular motion. Circular motion.
Sir, today this topic will also be in
Write the
the.
definition. Right. When the body moves along a circular path, along a circular path, then its motion is called. Then its motion is called. What? Circular motion.
Sir, in a fixed point.
Circular motion. When it is moving along a circular path. Another definition. When a body moves around a fixed point, then its motion is called circular motion. Circular motion. Next, a body which is moving in the circular path, whether it is accelerated or non-accelerated.
Accelerated.
Accelerated.
It is accelerated.
Right. In circular motion, body will experience the accelerated motion. Why it is said to be accelerated?
Change
Manya,
Keep on
velocity.
changing its velocity.
Manya J. Jain. Why it is accelerated? It is accelerated as it changes its speed. Why it changes the speed? As it changes the direction continuously. Right. In circular motion, a body changes its direction of motion continuously. Its direction of motion continuously, so that its speed changes. Next, another point. As Manya, you tell, what is the direction of motion of a body if it is moving in the circular path?
Rectangular motion.
It is. tangential direction. The body will be moving in the tangential direction. Right on. Next point. The motion of a body, the motion of, the direction of motion of a body, the direction of motion of a body moving in the circular path, moving in the circular path is, let it be in inverted comma, tangential. Written up. Just below that, you write the definition of tangent, and or else before that, let me do it. Draw a circle. Go for drawing a circle. Right. This is the object, and it is moving in the anti-clockwise direction. Let me show the tangential direction. Show the arrow mark as well. This is tangential direction. Over up. Then right. Tangent. What is tangent? It is the line that meets the circle at only one point. Is called tangent to a circle. Right now, a line that meets the circle at only one point. Only one point is called a tangent. It's called a tangent. Draw quick as possible. Last 2 points. Again, draw a circle. And mark its center. This is the radius. O is center of the circle. A is the point on the circle. At point A, I am drawing a line, perpendicular line. We call this as tangent. Next, last point, right? Formula to find out, side reading. Formula to find the speed of a body. Moving in circular path. Formula to find the speed of a body moving in a circular path. It is V is equal to 2 pi r by t. V is equal to 2 pi r by t. Circumference by time. You can also write r. V is equal to c by t. V equal to c by t. Where c is circumference and t is time period. Still, I have to give you the definition of uniform circular motion. Then we have some numerical problems on this formula, that is finding the speed of a body moving in the circular path. Let us discuss all these in tomorrow's class. Okay, now it is time up.
Sir, please, sir.
Once I remind, today evening from 7 to 7:45, you have performance step 3 through Google Form, and the chapter is motion up to equations of motion. Shall I give this also?
Yes, sir.
Huh?
Yes, sir.
Okay.
Yes, sir.
Only one question will be included. Only one question will be included.
Yes, sir.
Okay, with this, let us stop the class.
Excuse me, sir.
Thank you very much.
Marks, sir.
Have a good day.
Thank you, sir.